Okay, good morning. So, again, I thank the organizer for asking me to make this short introduction to the connections between INAF and LSST. What is INAF doing for LSST? Of course, what INAF is doing is very quickly said. It's INAF is, of course, you. So that's what you are doing and what you will do in the next years. So let me first stress this point by reminding you that the INAF participation to LSST has really been a bottom-up process, in the sense that it really started from an interest quite diffused among people in the INAF community, in all Italian astronomers, I would say. This is a short history. I'm not going through all the details, but essentially a couple of years ago, there was, after a first attempt in 2015, there was a widest interest collected in 2016, so several people started to talk again to trigger this participation. At that time, more or less, the division for optical infrared astronomy was established, and we were asked to step in the discussion. Then there was a nationwide call, and there was around 45 proposals were submitted at the time. There was a friendly, someone said bloody, process of reconciliation between the different science cases, which eventually went down to this magic number 15 PIs. And these 15 PIs purely by chance matched the number of people who the INAF decided to pay for. And so at the end of the year, the INAF board decided to approve the membership of 15 PIs to LSST. So this gained to INAF the status of international contributors, which means that INAF is committed to pay for 15 PIs, and I will show you later how much it costs, for 15 PIs, whoever they are to some extent. So the composition of the team may change in future, but we are committed to pay at least for 15 PIs. And as I will show you later, this is actually the tip of the iceberg of a wider community interested. So INAF decided to make a step forward and asked to the LSST Corporation to become an institutional member, so not a contributor, but a member. So this proposal was accepted. I think we were the first, after quite a long time, to submit a request to enter the LSST Corporation. This request has been approved in April this year. I will attend the meeting, the LSST board meeting in a couple of weeks from now in Tucson. I think this is an important point because it gives us, of course, we don't have a great leverage in controlling the project, but we may understand much better what's going on in the project. The LSST Corporation, the organization of LSST is quite complex. I'm not going into the details. So the corporation is only one of the actors in controlling the project, together with the OAPa, NSF, and the DOE. But it's certainly important for the scientific exploitation. So that's the place where you want to be if you want to understand what's going on, to look for collaborations and understanding also where some money can come from. So this is really a commitment and to be part of LSST at the highest level possible in the project. So we really trust this project. And of course, the reason for there was this great interest is the difference between what you get if you are just just live with the public data. You get, of course, you get something out of LSST even if you don't pay. But if you pay as a contributor, of course, you can do much more. So most of the most exciting science you can think about with LSST comes if you are a contributor, if you have your hands on the data, if you work on the tools to extract the information from the science, if you can suggest at least how, for instance, to organize the cadence or whatever. So that's the clear advantage in being a contributor. As of today, we have, as I said, 15 PIs. This is the updated list. Every year we can update the list. These are the names, the scientific interest, and which science collaboration in LSST they are interested in. So it's not the point is not going through the details. These names here are not fixed forever. Every year we revisit their engagement, and there have been and there will be changes in this composition. And the important point is, as you know, each of them carries 4 additional young scientists, postdoc, or in any case young scientists. So the overall up to 4 for each of them. So we can be as much as 75 INAF or in general Italian members in LSST have the right to work on the data as they come. So not surprisingly, if you look, last year we did a survey about the perception, how we perceive that our future will be and where we will be mostly engaged. So this is the fraction of time that the science community feels will be, the fraction of time we expect to be working on the different projects in all fields of astronomy. These, I think, are the 10 most important ones. And as you see, this was a Euclid-based slide, but as you see, LSST is one of the 10 most interesting projects for the Italian community. As you see, I mean, the numbers can be taken with some some grain of salt, of course, but it gives you a feeling of how crucial LSST is felt by the Italian collaboration. And of course, these 15, I mean, I haven't said, but these 15 may increase in the future if we decide so. So we may, in principle, you just have to pay more and you get more access to the data. Now, this comes with a cost. It's nothing, no lunch for free, of course. So the cost, each PI costs $200K spread over 10 years. So these dollars are indexed from 2013, so you should approximately think about 20K euro per year, hoping that we will still keep paying in euros for the next years. But, and the payment is due something from 2020 and beyond. So this is what we have to pay. In addition to this membership, we have to pay for the accessing the computing facility. Now, the original expectation was about $1,500 per PI per year. Actually, the more recent estimates have increased this number pretty much, because it goes to $1,000, not per PI, but per user. So if you come with a crew of 5 users per PI, you go up to $5,000 per year. So multiply this by 15, so you have a substantial increase in the cost that we shall pay to exploit the computing facility that the LSST Corporation will grant us. And it's, I should say, it's not even entirely clear that this will be enough for our needs. So we have to start thinking seriously if we want to develop something in-house or at a European level, in the European context, to use the LSST data to better exploit them. This is a discussion that is starting these days in many different ways, and I will be happy to talk more about this on offline. But again, I stress that this comes with a cost. So everything comes with a cost, of course, but in this case, it's pretty important that we exploit the LSST data as much as possible. So, of course, you are already engaged, so I don't have to advertise LSST here. I want to stress that I think the key message that made the INAF, the INAF board, well keen to accept these is the concept of synergies. Let me show what this means. This is an incomplete list of the projects that we are developing at least only in the optical near-infrared domain, with a significant INAF participation. So there are many of them, and I have not mentioned the space missions devoted to extrasolar planets, which are probably not very connected here. And so this is a time scale, it's a timeline, starting from more or less now. You have different categories of instrument. You have high resolution deep imaging, which is probably not very can be connected to LSST, because of course if you use LSST to identify very rare but very important objects to study, then you can follow them up with the 8 and 40 meters telescope in the future, one by one. But of course the obvious connections are with the multi-object deep spectroscopy, and we have a number of instruments again, and with instruments that go to the wide field. So in particular, we have a number of surveys, WEAVE, MOONS, Euclid, etc., which will come more or less at the time of LSST. If you have, again, the transient sky gives you candidates to study in more details. So we have a number of instruments designed to study with single object spectroscopy the transient objects. Of course, VLT, Espresso and TNG JARPS are the workhorse today, but I will show you in a few minutes what SOX can do. So this is just to give a feeling that LSST in the INAF strategy is not in isolation, but is part of a broader picture. And of course there are X-ray satellites and SKA, etc. I don't have slides, but are part of the picture in this framework. So let me go quite quickly through the various instruments. Let me skip nearly entirely the science. This is only, let me show this slide I like a lot. This is the peak luminosity versus the time scale of transient objects. And as you know, there is a gap in bright and very fast objects, and we don't know if these transients are not there because they don't exist or because we have not been able to detect them. And LSST will completely revolutionize this field by giving us zillions of targets to explore across the whole plane here. So quite quickly, let me just give you 3 examples of projects where we are investing a lot and we will have a lot of data, and where the synergy with LSST is obvious. So this is an invitation to exploit these synergies in the next years. One is the SOX at NTT. SOX is a single object spectrograph that will deliver spectra from the U to the H band, so simultaneously over a wide an extended wavelength range at medium resolution. And there are, of course, a number of science cases, and many of them are for transient spectroscopy of transient objects. The key point is that SOX is led by INAF, by Sergio Campana in Milan, and ESO will reward the SOX consortium with a lot of NTT time. We shall have access, SOX consortium, we shall have access to half of the year of NTT time per year over 5 years. So half of the telescope will be ours, and INAF itself contributes to 50% of SOX. So we have plenty of time on the most efficient spectrograph in this range of things that will ever be accessible. There have been a lot of, just to give you a feeling, is the toughest part of the discussion with ESO has been when ESO realized that with this way we can observe all the transient you may think of all the year. Okay, essentially all the transient you may think coming across during a year can be observed by SOX in granted time, leaving nothing to the rest of the community, and ESO, of course, was upset. So this gives you, and then we had to find an agreement on this. But this is just to give you a feeling of how many transient can be followed up with SOX, how many transient, of course, SOX is in the south, so all the LSST targets can be observed with SOX. On a different field, we have the multi-object optical and near-infrared spectrograph MOONS. That will be placed at the VLT and will be able to observe of the order of 1,000 objects per pointing in the near-infrared. And again, there are surveys that will be developed at medium resolution or at high resolution. There is a very clear science case for the infrared spectroscopy. Now Livia is here, can say much more than I can on this field, but of course the possibility of studying at high resolution the spectral lines in the infrared will open access to a detailed chemistry of a huge fraction of the Milky Way. And so this is clearly crucial for OAPa, for Gaia and VISTA on the one side, and for LSST on the other. And similarly, on the extragalactic field, you may study the properties of galaxy as a function of environment over huge scales. Essentially, the idea is that with this telescope, with this instrument, you may do a survey like Sloan, a redshift that was done, as you know, at redshift 0.1, 0.2. You can do the same volume of the universe at redshift 1.5. So it gives you an order of magnitude increase over what we have today. And again, it will cover the fields observed with LSST. So there is an obvious synergy between what can be done, say, for instance, on the deep drilling fields that you mentioned, with these kind of instruments. And again, INAF is participating in nearly 20% of this instrument. We shall have GTO, and we will have a hand-on experience on the instrument that we can use for future surveys beyond the GTO. And of course, there is Euclid, which is the other obvious wide field survey, pretty complementary to LSST for many cosmological applications. Is done by 3 surveys, the wide survey, a deep surveys, which is exactly like LSST if you want, plus the calibration fields. The yellow part, this is the sky, the yellow part are the Euclid reference surveys, so we will skip, of course, the galactic plane for obvious reasons. Euclid needs wide field imaging from the ground to complete the photometric redshift and other information. And LSST is the most obvious instrument to have this follow-up. And this is there are negotiations ongoing between LSST and Euclid. And so the possibility is that this gives you a feeling of how the 2 surveys will complement each other. So the green part is the standard area covered by LSST up to the equatorial 0 degrees. And there is the possibility that LSST also follows to a shallower depth up to +30 to cover additional areas. And as you know, there are about 100 people in INAF that are working on Euclid, so that's obviously another examples of where the synergy, the combined use of LSST and additional data can really make the INAF contribution, I would say, even outperform what we think we can do today. So I think this was the last slide. So again, it's an invitation for you to think as much as possible what can be done on LSST data. Thank you.